So welcome to this TwinShip Horizon Europe project. Today I'm going to talk a little bit of overview of the project. Some of you are already familiar, but there are some people who are new to this project. I think there's a good number of people also joining online to learn about this project. And this is an dissemination activities under this project. We plan to have this type of workshops and conferences in the future to give you a brief overview of what we are doing within this project itself, and then how other technologies and also the stakeholders are related to this project itself. So you would see probably every 6 months we are conducting this type of knowledge dissemination activities under this TwinShip project. So as I said, my name is Prasad Pereira. I'm from UIT Arctic University of Norway, working as a professor, and also I have a part-time position at Sintef Digital. So this project was funded under this call, under this call in the Horizon Innovation Action. So the title is this Integrated Digital Twin Framework to Enable Green Ship Operations Towards Zero Emission Vessels. You can see we somewhat covered a good portion of the Europe by having various partners on board in this project. So the project period is 3 years, starting from February of 2025. We have a total budget approximately 9 million euros. So we started on February 1st and 2025. We expect to end by 31st of January 2028. So the project URL is there. It's twin-ship.eu. So if you are interested getting more information on this project itself, you can go to this link, and most of the publicly available documents and information are documented there. For example, our publications are there, and also deliverables, which is public, are also listed there, where you can download and read about the progress of this project itself. And then there are some links to this European Commission website, where the informations on the project itself are listed. So the partners-wise, this is our project consortium. UIT, the Arctic University of Norway, is leading this project, and followed by we have Sintef, Vatsala, NTUA, National Technical University of Athens, ICCS, which is under NTUA also. And then we have a Grimaldi Group, Stena Line, Kundi Hansen, Valencia Port, and also American Bureau of Shipping. Software development side, we have this Assist, UBI Tech, and 52 North. They are contributing towards developing many of the software applications, and also Bound for Blue, which is wind energy web technology developer. So they are also part of this consortium. So as you can see, we have a good amount of universities, research institute, technology providers, ship owners, ship designers, port, and also class, along with software development foundations, and also renewable energy harvesting technology providers be a part of this consortium. So it's a really good mixture of that. So these are some of the detail-wise how the distributions of the consortium is presented. We are covering quite a good portion of the Europe in this collaborative project. So if you say a little bit of a summary of this TwinShip project, so we, as I said, this is a collaboration between maritime technology and solution and service providers, ship designers, shipping firms, classification society, ports, software developers, research and academic bodies. And core of this project is circulating around this unique open source digital platform, enriched with various data from various ship owners. So the digital platform is called this Vessel AI platform. So here we are introducing machine learning and AI applications under this digital twin model and also under this decision support system. But also, you should remember we are not just using machine learning and AI, but also existing knowledge has also been utilized in this process. So we have a ambitious, yeah. Okay, within the slides, right? Yeah, a little bit of a technical challenge, technical issue. Let it. Is he accepting? I don't think he's in the right room. He's not in the Teams room, right? Are you trying? So he's in a different Teams room, I think. Yeah, so let me continue until we fix that problem. So in that way, we have ambitious emission reduction targets to achieve within this project itself. Of course, within the project itself, we are planning to reduce up to 20% of the CO2 emission, but also we will set up some sort of a roadmap towards reducing this greenhouse gas emissions 30 to 40% by 2030 and 80 to 90% by 2040, and then achieving net zero emissions by 2045. Of course, with respect to the 2008 levels, but you have to understand also we are using this existing and future green fuel and technologies and also renewable power sources, and then concept of unmanned vessels in this project to make sure these targets can be achieved by combination of these type of practical and possible solutions rather than just throwing numbers at as publications. I think technology-wise, we have these somewhat technologies are available, but I will talk a little bit later also. We would expect these technologies to get matured while we moving towards the future. And also this futuristic unmanned vessel concept is something really important for this project. We will present this concept as a part of the TwinShip project. So in that way, we would kind of tell you how we can achieve this type of net zero emissions by 2045 by combining multiple technologies. So the renewable energy will play an important role in this pathway. But of course, you can imagine when you have a renewable energy harvesting devices, you have to navigate in a somewhat moderate or rough weather conditions. So then human comfort always going to be a challenge in such situations. You will overcome these type of situations by having unmanned vessels, at least in a conceptual level for now. But this is the one of the possibilities in the future. So under this project, we are kind of pushing these boundaries of the innovations and make this shipping industry more sustainable towards the future. So let me say a little bit about the project objectives. So it includes mainly the development of integrated system of systems as a digital twin. So when you're thinking about developing a model for a vessel, then of course it's a combination of multiple systems. Yeah, so we are approaching towards more greener ship operations. This would include the whole ship life cycle, from this ship design phase to operational and maintenance phase to also ship scrapping phase. So the second objective is that this adaptation and enhancement of our open digital platform, which is developed by Vessel AI project. So the platform itself also called Vessel AI platform. So this was a previous Horizon H2020 project. We are getting that technology enhanced under the TwinShip project and projecting towards the future of this field. So this is also important a point. So since if you have an open source, open platform for people to develop technologies for the future, I think that will open up the uh, it in a way it kind of push the uh, just the technical issue. Yeah. Okay. Now you should be able to hear, right? Okay. Let me continue with that. So when you talk about the Vessel AI platform, this will be an open platform which is available for many people uh, for the future development. So we will try to keep it in that way. That way, for the future projects to be developed in this same platform. I think that will give you added value for many researchers who are struggling with finding infrastructure towards developing this type of application. And when you think about many machine learning and AI applications, they are developing pretty exponential speed. So the platforms has to adapt towards this type of situations. Often commercially available platforms may not have the capabilities or features to be done. So this is kind of research platform for us, which has higher flexibility to develop future applications. So the objective is to develop this vessel data cloud space. When you collect data from various ships, I think we're looking into structuring this data in a more meaningful way. This is not just the database, but also enhancing the relationships between various systems of systems within the ship itself. I think later stage when you're looking into developing more complicated machine learning applications like multimodality type applications, having these data cloud space with knowledge graphs and ontologies is really useful because the data relationships can be served between this type of environment. So that is the kind of another contribution coming out of this lesson layer platform. It has some features, but will also further enhance these features. And the third objective is to establish this model evaluation methodology and also standard, not just developing digital twin models itself, but also I think we need to have some sort of evaluation frameworks to make sure these models are doing what it's supposed to do. Often we evaluate these models from outside, but since we're dealing with some of the machine learning and AI applications, we also like to learn how the model can evaluate internally. So the model evaluation framework has internal model evaluation framework as well as the external one, and also hardware in the loop type of testings where you can convert between to the software and the hardware side of various technologies and interconnect that. Of course, some tools they're having their own limitations, but in the future we would expect these boundaries will further expand. And if you're thinking about AI and machine learning and with including the explainability, I think this model evaluation methodology will play an important role. And also we contributed towards developing the standards on the digital twin. There are data related associations working on standardization of the digital twin, so we will also contribute towards that. And the next objective is to have this data quality governance strategy. When you get data sets from various ships, as you can imagine, there can be quite a lot of data related anomalies are there. It can be a sensor faults or a system abnormal event. I think one way or another, we have to clean up this data to build better digital twin models. So because of that reason, we have this data quality governance strategy also. So at the end, we're going to validate this digital twin as well as this digital support system under real world pilot studies. We have three vessels collecting this data
from Grimaldi and Stena shipping companies, and then we're going to develop digital twin on top of their data sets. And also we have this one futuristic vessel concept, as I mentioned before, unmanned zero emission, net zero emission vessel. We will be able to also make that vessel within our TwinShip project. Then, of course, the decision support system, which has actually three layers of decisions: short-term decisions, medium-term decisions, and long-term decisions. So the short-term decisions based on technologies like weather router type of application. We're going to utilize a weather router with these pilot study vessels and show certain percentage, probably up to 20% of the energy can be saved between this digital twin and decision support system application. And also we have a medium and long-term assessment. This is looking into the environmental impact assessment and then life cycle costing as a part of that decision support system. So as the final objective, our expectation is to have this industry-wide adaptation of this technology and also dissemination of this knowledge throughout, especially within the European community, to share this, share this information. I think as a part of that, Kostas will talk a little bit about that in a later stage. NTUA, National Technical University of Athens, is hosting a master's program, which is also kind of outcome of this TwinShip project on the digital twins and decarbonization. So these are the activities we were going to do, and also in the future we will probably publish a book, a textbook related to this project, and which can also be used in various courses in the future. So I think that is kind of our academic contributions in this project towards the future scientist. So this is our innovation structure within the TwinShip project. As you can see, the top layer is generally covered by various data sets coming from various partners, including ship performance data, weather data, and port data, and also some ship operational and maintenance data, current and future green fuel and technologies, and also the weather data often available in public domain. So some of the objectives I have mentioned here, we categorize into innovations, including this vessel AI digital platform, and also vessel data cloud space, where we have the structure of our data, and then data quality governance strategy, where we have evaluation of the quality of the data. And the middle layer, you can see this digital twin development tools, digital twin model, and also evaluation methodology, pretty much covering the whole digital twin ecosystem. And bottom layer, we have this decision support system, including this voyage optimization, environmental impact assessment, and life cycle costing. So eventually, smart decisions in ship design, construction, operation, maintenance, and retrofitting also, and scrapping is kind of outcome coming out of this project. So we plan to have on board and onshore versions of these decision support systems, but I think the technology is changing so fast. We probably have everything onshore, since it's also kind of requirement for the ship owners. And then, of course, vessels can communicate through applications like large language LLM-based applications to get the information they need through various online platforms. So the way we think about how the technology will develop also kind of changing or maturing throughout this project itself. So this is kind of overview of what we have mentioned as the project innovations. So when you're thinking about the digital twin model development, of course, we plan to cover whole life cycle of the ship. Starting from ship design phase, where we have various type of ship design information. So also model scale testing data, and also full scale testing data, some situation. So we combine these informations to create this engine propeller combinator diagram. Of course, this is a more conceptual level idea. where you can kind of project most of the data you collected from the ship design phase into some sort of theoretical base. And also hydrodynamic simulations, CFD calculations can also be part of this area. And then we developed this vessel data cloud space by combining the on-ship operational data and also greenfield technologies data. But this is we projecting on top of this engine propeller company diagram, because that theoretical foundation will give you some level of consistency within the data sets we are collecting from the ships. If not, of course, we can go back and kind of understand why these variations are there. And then the next step of this digital twin model development cycle is this TwinShip integrated digital twin framework. In a more higher level, these vessel data cloud space is playing these knowledge graphs and ontologies to structure this data towards building more comprehensive vessels with their ship systems and keeping the relationships among these ship systems. And more low level, we will run various machine learning and AI algorithms. Of course, basically what these algorithms are doing, clustering and regression. So these applications are always going to be there within the project development side. And then the model evaluation framework, as you can see, we have various type of evaluation methodologies, which is including hardware and loop testing, internal model evaluation, and also testing. So this is somewhat this digital twin model development cycle, and then it's supported by the ship life cycle, feeding various type of informations throughout this development process. And you can see the outside we have this decision support system, which is running this voyage optimization, life cycle cost analysis, and environmental impact assessment type of applications to make the required decisions within this project. So there are 4 pilot vessels, 3 pilot demonstrations, 1 conceptual vessel, supported by ship owners like Grimaldi, Spain, throughout this project. So they will work with us to make sure these digital twin models are more productive towards their shipping industrial applications as also for their requirement. And also, they're also supporting us with various data sets. I think this is one of the key important points when we're talking about developing digital twin. Without the proper data, I don't think we would be able to do much work in this domain. So data is playing a crucial role in this project. So this is the project work package structure. So it's kind of going along with 8 work packages. So starting from the understanding of the requirements, model evaluation frameworks, and ship performance KPI. Then we're moving towards vessel AI platform development in work package 2, including the data. So the work package 3 we are working on this engine propeller combinator diagram and also the vessel data cloud space, followed by a 4th work package. We have this digital twin prototype development. Work package 5, we will work on this operational and future vessel decision support system. Followed by work package 6, we have the demonstration, validation, and impact analysis. In 7, we talk about dissemination, exploitation, and communication, and the last work package is about the project management. When you come to various technologies, here we proposed multiple technologies which we use some selected ones within the project itself. So some will be developed in a more theoretical way and then incorporated into the digital twin. Of course, some data available for some technologies, but the main point is these technologies has efficiency level, current efficiency level, and future efficiency level, We are looking also into how mature these technologies between next 20 and 30 years period to support these net zero emission target in the future. So there are multiple technology providers working with us on this project to support integration of these technologies by providing their knowledge and competence. I think that is also another strong point in this TwinShip project we progress with further. So this the management structure. I don't go through the main areas, but it's typical Horizon Europe project should have a management structure, and it is kind of existing within us. Yeah, so I think that's pretty much the end of my presentation. So I think we won't take questions from the audience, but from the online. But if there are
There's already one question from the chat.
Okay, okay. Yeah.